Hello everyone, welcome back to the ECE 9013 course. This is the presentation from week 2 in which we will be discussing branching and iteration in Python. So in last week's presentation we discussed the history of Python, some of the syntax and semantics in Python. We presented scalar objects, some simple operations, and presented the concepts of expressions, variables, and values. In this week's presentation, we are going to discuss briefly the concepts of string objects. We will also present how to do branching and how to implement conditionals in Python. We'll also discuss the importance of indentation in Python and finally present how to perform iterations and loops. So starting off with strings. Strings are defined as a set of letters, special characters, spaces, and digits that are typically enclosed in single quotes or quotation marks. So we can see here, for example, the variable hi is defined to be a string called hello there with double quotation marks. Note that we can perform multiple operations on strings, such as concatenating strings. So, for example, here we define a variable called name and we assign the value Khalid to it. We then define another variable called greet and we assign the value of hi and name. So the output would be hello there Khalid. We can also perform some other operations. So for example, if we implement this line, the name Khalid will be repeated 3 times. To print out a variable or a result to the screen, we use the keyword print. So for example, here we can define a variable x to be an integer 1. Then we can print this variable onto the screen. We can then, using casting, transform the integer into a string, which we call here x_str, and then print the sentence, my favorite number is, and then we put the value of x, dot, and then x would be equal to x. So trying these out will help you visualize how this print command works. So this keyword prints, what it does is that it displays whatever is in the quotes. Another concept to consider is how to give or ask the user for an input. And this is where we use the input command. So here we are asking the user to type in anything, and whatever the user types and then presses enter is stored into text, and then we can print that out. So input gives you a string. So in order to transform it back to a number, in case you are asking the user to input a number, you would actually have to cast it. So basically transform whatever number that is given as an input back into an integer before you proceed with any other operations. So this was a brief overview of the string objects, the print command, and the input command. Now moving on to the idea of comparison. These show the possible comparison operators that can be performed on integer variables, float variables, and string variables. So assuming I and j are variable names, we can compare between these variables to evaluate a Boolean. So we can either compare if I is greater than j, I is greater than or equal to j, less than j, less than or equal to j, if I is equal to j or not equal to j. So note here that to check whether two variables are the same, we would actually have to write double equal, not just one equal. And this is often used as part, or these operators are often used as part of conditionals. So this is just a brief overview of logic operators. So not of A is the opposite of A. So if A is false, then not A is true, and vice versa. A and B is only true whenever both A and B are true. A or B is true whenever any one of them is true. So this table provides you with all of these different possibilities. This is here an example. We define two variables, pset time and sleep time. So if we implement this, the output would be false because sleep time is not greater than pset time. Another example is if we define drive to be true and drink to be false, and define another variable to be both drink and drive, printing that would give us false because drink is false. So this is just an illustrative example of the conditionals. So if right is clear, go right. So here we define 4 different possibilities in order for the user to reach the free food. So if we actually implement these rules, we would actually see that the user would drive along this path, potentially reach here, then go back, and then check that the right would be clear, and then continue until they reach free food. So this is the general structure of conditionals or branching in Python. So we can either have a normal if statement with a condition, and then if that condition is true, we would implement a series of expressions. Note that we have here this double points to indicate that this is a block of content or block of code to be implemented if the condition is true. This is an if-else. So in this case, we are checking whether if a particular condition is true, we implement a specific block of code. If not, we implement a second block of code. So this is what we call if-else. We can also do multiple ifs. So we can start with an if condition. If that's not true, we can check for another condition. And this is where we see if-else. And this can be repeated multiple times, dependent on the number of conditions. And then have one final statement. So we would only evaluate the expressions in the block for which the condition is true. Note that indentation matters in Python because this is how we denote the blocks of code. So for example, if we want to perform multiple expressions as part of one big condition, we would have to have it with the same indentation, like we see in these two lines. These two lines will be implemented or executed whenever this condition is true. Another concept that we mentioned earlier is whenever we want to check if two variables are the same, we would have to use double equal. So if we use x equal to y here, we will get a syntax error because x equal to y is an assignment operator not a conditional operator. So if we have a condition here written as if x equal to y, we will get a syntax error. It should be written as if x equal to y, and then that's a conditional that we actually check. In the next part, we will be discussing iterations and loops.